Hello everyone. In this video we will learn how to integrate functions of the form cosine to the power an even number times sine to the power an even number. Remember that before we learn how to integrate products of powers of sine and cosine when at least one of these powers is odd. Now we are completing all possible cases. So after this video, you have to be able to integrate any function which is products of powers of cosine and sine. Okay, so let's start with simplest possible case here. The power of cosine is 0, which is an even number, times sine squared. In these cases, there is only one way to move on, and that is you have to use what is called power reducing identities. We have sine squared, let me write it in black, sine squared x is equal to half of 1 minus cosine 2x. This is sometimes called half angle formula, or and it can be obtained from the double angle formula for cosine 2x. Okay, so how does that help us? So if I replace sine squared x by half of 1 minus cosine 2x, well, I will get, using the linearity of integral, I'll get two integrals. The first one is an easy integral to do. That's integral of just one number. The second integral is cosine of 2x. Well, this can be integrated by substitution, but in general, you can add this to your table of integration. If m is non-zero, integral of cosine mx dx is 1 over m sine of mx. And again, this is obtained by substituting u equal to mx. Okay. Well, for sine also we have something that we will use in a minute. Integral of sine of 1 mx is 1 over minus 1 over m cosine mx. So here then what we have is the first one gives me half of x, the second one gives me half of another half, this is m, half of sine of 2x, then plus c. And that is x over 2 minus sine 2x over 4 plus c. Okay? So this is the strategy we have to take. So the key point when we are dealing with even powers of sine and cosine is what is called half angle formula, or your book likes to call it power reducing identities, which is, okay, for sine we already saw it's half of 1 minus cosine 2x. For cosine we have 1 as well, so this is half of 1 minus 1 plus cosine 2x. And the reason that we calling it power reducing is that you see on the left hand side you have square, but on the right hand side you have two terms. One is just constant, the other one, the power of the trigonometric function is 1, so you reduce the power, though the angle you have inside is a little bit different, twice as the angle you had at the beginning, but the power is reduced. Okay, So let's do another example and see how this works for other examples. Okay, I have here the next case, cosine squared x sine squared x. So as the general strategy says, well, when it comes to products of even powers of sine and cosine, replace each one by using power reducing identities. So replace sine squared by 1 minus cosine 2x and then dx. And cosine by 1 plus half of 1 plus cosine. And when you do that, you're not done. You need to expand this. Well, I will bring these halves together and then write the rest. So here is 1 plus something times 1 minus something, yes? So that means that a plus b times a minus b will be a squared minus b squared. Okay? Well, when you do that, then you notice that, okay, I can separate now these integrals. And the first integral is a good integral, but the second integral is again another integral which has cosine square in it. Well, that means that before you see that sums of powers of sine and cosine was 4. Now you're dealing with an integral which has only cosine, and the power for the cosine is 2. It's 1 down. What shall I do with that one? Okay, you repeat all the techniques you know again. So here it means that I will integrate the first one. The first one will give me x over 4. The second one, well, I will use the power reducing identity. Cosine squared of something is half of 1 plus cosine of twice as that something. So it's here, you see, if it is x in the left hand side, on the right hand side it will be 2x. Here, the left hand side itself is 2x. You multiply it by 2, you get 4x. So that will be cosine of 4x dx. Okay? Now you can separate again another time. This will be multiplied. This will give me integral of 1 over 8. So that's x over 8 minus integral 1 over 8 of integral of cosine 4x dx. So that's another time using what we had before, cosine of, okay, so let me, x over 4 minus x over 8 gives me x over 8 minus cosine of 4x dx gives me 1 over 4 sine of 4x. There is an 8 there, so it will 1 over 32 sine of 4x plus c. So after using the power reducing or half angle formulas, we did expand it and repeat the process. Sometimes you have to do exactly the even power strategy, or maybe you need to use the odd power strategies as well. Okay, let's do another example here. Find the average value of the function cosine to the power of 4 on the interval 0 to pi over 4. Remember that that average value of a function f on an interval over an interval ab is given by this 1 over the length of the interval and then multiplied by the integral of that function on that interval. So in this case, we are then looking for 1 over pi over 2 minus 0 times integral 0 to pi over 2 of cosine to the power 4x dx. So that's the value we have to find. Okay, I will start here, 0 to pi over 2 cosine 4x dx. So now I want to use what I have learned. So I will turn this cosine to the power 4 to cosine squared to the power 2 dx. Why square? Because I know how to change this guy to something which has lower power. So why do I have 4 there? This is pi over 2. Then, so that means that I have to go ahead and then replace that. 1 over 2, 1 plus cosine 2x to the power 2 dx. Let me see, I am missing one bracket. And then when you expand that, that's always the next step. Expand it, you get 1 plus 2 cosine 2x plus cosine 2x. Cosine squared 2x. And now we have to integrate each one of these guys. But before I do that, let me just go one more step here, because these guys are easy to integrate. How about this one? Well, I will use another time the so-called half angle or power reducing formula. And remember that power reducing cosine squared is equal half of 1 minus cosine of twice as whatever angle is there. So here was 2x, twice as that is 4x. So then we have 1 over 4, 0 pi over 2. There's 1 over 2. This is 3 over 2 plus 2 cosine 2x. And then there is plus 1 over 2 cosine 4x dx. Now apply each rule that we know for each one of these terms. So this is 3 over 2x. The other one is 1 over 2 sine of 2x. So that will give me sine of just 2x plus 1 over 4 sine of 4x times 1 over 2. So it will be 1 over 8 sine of 4x. And we go from 0 to to pi over 2. Okay, then let's plug in everything there. 1 over 4. This is 3 over 2 pi over 2 plus sine of pi, 2 times pi over 2 is just sine of pi. And this is sine of 4 times pi over 2 is just 2 pi. Okay, minus 1 over 4, plug in 0. 3 over 2 times 0 plus sine of 2 times 0 plus 1 over 8 sine of 4 times 0. Well, it is 0, yes. So this whole second part is 0. This is 0. This is 0. The only remaining term is this part here, which is 3 pi over 16. So remember that we were looking for average value, and average value was 1 over pi over 2. So I'm plugging in this guy back up to that formula. So that will give 2 over pi times the number we find there is 3 pi over 16. And that cancels with that, that cancels with that. This is 8, and this is 3 over 8. The average value of cosine to the power 4 is 3 over 8. Okay? So Let me, before I finish the video, just quickly summarize what we had for the even powers of sine, products of sine and cosine. The first thing is that the key point is to use what is called half angle or power reducing formulas, identities. But to go there, so since the powers are even, you can always do this small step that will give you sine square or cosine square to power something, and then replace square of sine or cosine by the formulas in the first step. Then expand this thing as we did in the example. Expand, what you will get will be powers of cosine. And then when you get there, you have to go back and apply what you had from before and deal with each one of these guys separately. And then find the value of each one and then put it there. Okay? So this way you have all the tools to be able to integrate even powers of sine and cosine when they multiply.